All right. Well, tangent and cotangent are reciprocals. So our cotangent of x is arctangent of reciprocal of x. Similarly, cosine and secant are reciprocals. So arcsecant, going backwards, of x is arc cosine of 1 over x. Likewise, cosecant and sine are reciprocals. So arc cosecant of x is arc sine of 1 over x. So we'll evaluate those that way. Now, here's a question of finding trig of arc trig. Cosine of arc sine, tangent of arc sine, sine of arc cosine, tangent of arc cosine, sine of arc tangent, cosine of arc tangent. Well, we can solve this by drawing some reference triangles, like here. So for example, cosine and tangent of arc sine. We draw a triangle. This angle here is arc sine, which is opposite over hypotenuse. So let's make this triangle with opposite equals x, hypotenuse equals 1. Then by a bit of Pythagoras, this other side is square root of 1 minus x squared. Then having gotten this triangle, we say that the cosine of this angle is adjacent over hypotenuse, this over this, which is root of 1 minus x squared. Tangent of this angle is opposite over adjacent, therefore x over root 1 minus x squared, like this. Now here we're taking sine and tangent of arc cosine. So here we'll draw a right triangle with this angle equaling arc cosine, which equals adjacent over hypotenuse. So make the adjacent equals x and the hypotenuse equals 1. This third side, after a bit of the use of the Pythagorean theorem, is root 1 minus x squared. And then we can read off the sine and tangent of this angle. Sine of arc cosine is opposite over hypotenuse, therefore root 1 minus x squared. Tangent of arc cosine is opposite over adjacent, therefore root 1 minus x squared divided by x, like that. Now here we're taking sine and cosine of arc tangent. So here's a right triangle, here's an angle arc tangent, which equals opposite over adjacent. So make this opposite side equal x, this adjacent side equal 1, and then now the third side will be root of 1 plus x squared rather than root 1 minus x squared. And then, okay, sine of arctangent is opposite over hypotenuse, x over root 1 plus x squared. Cosine of arctangent is adjacent over hypotenuse, 1 over root 1 plus x squared. Now, okay, so here's some examples. What is the cosine of arcsine root 2 over 2? Okay, here's a right triangle. This angle is arcsine root 2 over 2. That's opposite over hypotenuse. Here's root 2, here's 2. This is root 2 as well. Cosine of that is adjacent over hypotenuse, root 2 over 2. Here's tangent of arc cosine of minus root 3 over 2. Okay, here we're going to put an angle in quadrant 2. It's arc cosine of minus root 3 over 2. That'll mean this x value is negative root 3. This diagonal, this hypotenuse is 2. And by a bit of Pythagoras, you get that this side is 1. And you can easily enough see that this will be 30 degrees, and therefore this is 150 degrees. Tangent of this will be opposite over adjacent, 1 over minus root 3, so minus 1 over root 3, or minus root 3 over 3. Cosecant of arctangent 1. We draw a right triangle. This angle is arctangent 1, opposite over adjacent, 1 and 1. Therefore, the diagonal is root 2, and cosecant is hypotenuse over opposite, root 2 over 1, or root 2. Now this one gets complicated. Cosine of arcsine root 3 over 5. All right, so let's start. This is approximately 28. I didn't do 27 or 29 because they weren't sufficiently similar, so I made up some numbers. I think the book has root 2 over 7 or some such, I'm not sure. Anyhow, so this angle here in this right triangle is arcsine of root 3 over 5. So that'll be opposite root 3, hypotenuse 5. And then to find this side here, well, square root of 5 squared minus root 3 squared, after a bit of calculating, it's root 22. So root 22, root 3, and 5. cosine of this angle is adjacent over hypotenuse, root 22 divided by 5. Here they ask for cosine of arctangent u. What's that? Well, right triangle. Call this angle be arctangent u. Tangent is opposite over adjacent, so make this u and then make this equal to 1. And then with these two sides, 1 and u, the third side by Pythagoras is the root of u squared plus 1. And cosine is adjacent over hypotenuse, therefore 1 over root u squared plus 1, like that. Now here's tangent of arc sine u. What's that? Right triangle. This angle is arc sine u, which is opposite over hypotenuse. So opposite is u, hypotenuse is 1. After a bit of Pythagoras, this third side, adjacent side, is root 1 minus u squared. Tangent of this angle is opposite over adjacent, therefore u divided by root of 1 minus u squared. Okay, now here we have sine of arc secant u. Well, hold on. Now, arc secant of u is arc cosine of 1 over u. So here we go. Here's a right triangle. Here's a angle of arc cosine of 1 over u. So that's 1 here for adjacent over u for hypotenuse. And then, oh no, oh dear, I have made a mistake. Because if the hypotenuse is u and one side is 1, then this third side is not root 1 minus u squared, but root u squared minus 1. So this is my mistake, and this is page 4, 3 to page 4, number 61. Square root of u squared minus 1. I get honked. And so that being the case, sine of this angle is opposite side over u, and so this should be root of u squared minus 1 divided by u rather than this. My mistake. My apologies. I hope I didn't make other mistakes like that. Here we go. Here's cosine of arc cosecant of u, and that's cosine of arc sine of 1 over u. So let's make this angle be arc sine of 1 over u. That's opposite over hypotenuse, 1 over u. Okay, this will, be root 1 minus u squared, not the other way around. And cosine is adjacent over hypotenuse, root 1 minus u squared divided by u. Okay, I'm going to have to change this problem in the Canvas notes. And let's call that